Good morning, everybody. My name is Atreya Manaswi. I'm a 10th grade student at Orlando Science High School in Orlando, Florida. I've been working with the UFB lab and also the USDA for the past 4 years, so since the 7th grade. So I'm going to be speaking on small hive beetle biology and control and sharing some of my research using organic agents. So to begin with the biology, the scientific name for the beetle is Athena tumida, and they were actually endemic to sub-Saharan Africa prior to the 1990s. However, in 1996, we saw the first report in the Carolinas, and then in 1998, the first official infestation was reported in our home state, Florida. Ever since then, these beetles have been spreading all across the globe, wreaking significant negative impacts on the global industry. These beetles are described as opportunistic scavengers in the literature. They destroy honey and pollen stores, and they also damage catkins and comb, which significantly stresses the comb. Their presence is also thought to be a marker in CCD or colony collapse disorder. This is a picture of the adult small hive beetle. You can actually sex these beetles. I've done this a lot in my laboratory research. So this image on the bottom right is what it looks like when you sex the beetle. One of two things happens. Either a very long appendage shoots out or a short appendage shoots out. So if the first thing happens, then it indicates that it's a female. That appendage is an ovipositor. It's almost like an egg-laying machine gun. The female is able to take that ovipositor and stick it into cracks and crevices within the hive, and this is very suitable for laying eggs and reproduction. The short appendage indicates that it's a male, and this is a phallus. So there are 4 primary stages in the life cycle of a small hive beetle. The first stage is the egg stage. So it takes 2 to 4 days for these eggs to actually hatch. The second stage is this larval stage, and these larvae are really the root cause for the damage in the colony. They feed for 7 to 10 days. After that period, they exit the colony and then pupate in the soil. This happens for 3 to 6 weeks. And it's generally that the moist soil and a humid environment is normally what's favorable towards these beetles. Now, after that period, the beetles will emerge as adults and develop that reddish-brown hue in 24 to 48 hours. Something I'd like to note here is that given optimal conditions, this 2 days, 7 days, and then about 3 weeks, all that together is roughly 4 weeks. So it takes 4 weeks for that beetle to develop from this egg to a fully mature adult. And the lifespan for this beetle is 24 weeks. So 4 times 6 is 24, meaning that given suitable environmental conditions for reproduction, we can see up to 6 consecutive generations of these beetles inside a hive at any given point, which really goes to show that these infestations can get out of hand. Now, as I mentioned, the larvae are the main cause for the damage. They appear in very large numbers, often in the hundreds or the thousands. There's this yeast intimately associated with the feces of the larva, as our first presenter mentioned, and it's called Caudium omri. So this yeast ferments the sugars in pollen and honey, which causes the release of this volatile odor compound called isoamyl acetate. Now, when isoamyl acetate is released from the colony, it serves like a calling signal to other beetles in the vicinity of the hive and tells them that there is a storage of food here. Now, brood rearing will actually cease when this event occurs, and what you see here on the left is called a slime out. The beetles will abscond entirely, and it's a very dirty situation. Now, coming to the treatments, there are 2 main chemical agents that are used for treatment of this pest. The first is Checkmite. The active ingredient in this is 10% Cobophos. So these are pre-coated strips that are applied inside of the hive, and it functions through either dermal contact or ingestion. The second agent is GuardStar, which has a 40% active permethrin concentration. Whenever it's applied in the soil as a drench, it functions to kill the pupae of the beetle. So looking at how these are applied, Cobophos is applied during stages 1 and 2, and it targets the adult small hive beetles. The permethrin, which is the soil drench, is applied during stage 5, and it's called GuardStar. That's what it's sold as. Now, coming to the organic treatments, this is actually what I did my research on. There are a variety of agents that do exist, such as diatomaceous earth. It's placed in the vicinity of the hive. It dries up the cuticle of the insect. There's also nematodes, also as the first presenter mentioned. These are entomopathogenic nematodes. So once they're released in the soil, they enter the beetle, the pupae, through an orifice, either the mouth or the anus, and then they make their way to the gut where they feed as a parasite, killing the beetle from the inside. But what I focused on was in-hive traps. Specifically, what you see on the screen is the beetle blaster trap. And these have attractants inside of them. So these attractants are normally compounds that are odorous. They function to lure beetles through their scent that are inside the hive into the traps, and then they kill them. So a very commonly used attractant is apple cider vinegar, and that's something that I tested in my study. So coming to my research, I had 2 phases in this project. Each was a year long. Phase 1 was where I evaluated 7 organic, inexpensive, and odorous compounds in an extensive field trial to see which one would be the most attractive to the small hive beetle. And then phase 2 was developing a blend based on beer, which was found to be the best compound by far from year 1 of the investigation. And so phase 2 is really refining beer and creating a concentrated solution. It's almost like this blend, it's almost like beer on steroids. Sorry for the lack of scientific terms, but that's the closest analogy. Now for phase 1, I evaluated 7 different organic agents. The first was apple cider vinegar, mango puree, and cantaloupe puree. They both had 2% boric acid concentrations as a lethal agent, yeast, peanut oil, grapeseed oil, and beer. You may be wondering why in the world were these compounds chosen? This is based on prior study findings. So the literature has shown that these beetles can fundamentally feed and reproduce on tree sap, rotting fruits, and such things. And based on that, these things were chosen. Now, this is an image of the mini beetle blaster trap that I was using in my research. It's a 6-inch trap. This is cantaloupe puree that's been used with the boric acid. All these black specks are beetles that have been captured. So this image of me is in my field trials with my beekeeping suit, and you might be thinking, what a responsible young beekeeper, right? That's completely incorrect. I was stung dozens and dozens of times while in the field, and it was a very eye-opening experience for me, also very painful. I got stung in the foot, hands, everywhere. It managed to make their way into my suit somehow, and it really opened my eyes and taught me about the hardship that goes into beekeeping and how difficult it really is to put food onto our plates. So again, a very eye-opening and humbling experience. Now, I had a trap design, or a study design rather, that ran for 6 weeks using 24 honeybee colonies, which is over 1.2 million bees. And how it worked is I would have these organic agents inside the traps, placing them each week and then extracting and replacing them. So this was a randomized trial. You can imagine it this way. I had my traps, I would go into the hives each week, then come back the following week, extract those traps, and then replace them randomly. This way, or in this manner, rather, I was able to get a weekly beetle capture for each of the treatments and replace them with fresh baits to see how they were doing across the 6-week study duration. And if you remember, this year was 2020 during the pandemic. All labs were closed during this time, so what I had to resort to was using my mom's kitchen to count these beetles. And oftentimes they would get loose, so we would have beetles flying around in the house. Now, this chart basically summarizes the raw beetle capture throughout the course of the 6 weeks for this study. You can see here, beer is by far the best treatment in this Pareto chart. You can also compare this to apple cider vinegar here. This is the raw beetle capture. Something interesting to note with this Pareto chart is something called the 80-20 rule, or the Pareto principle, which basically states that if you start at this 80% mark, trace horizontally and then down vertically, there's 2 segments that are established. This segment on the left here, 20% of this, 20% of the beetle capture of beer, cantaloupe, and peanut oil to some extent, 20% of that accounts for 80% of all of the beetles captured throughout the course of the study. And then really shows the significance of these treatments, beer particularly. Now the findings from phase 1 or year 1 were really that beer was by far the best treatment for small hive beetle capture.
Okay, so
Question?
I'm a beer drinker. So what kind of beer?
Yeah, so the beer used in this study was Miller High Life. That was Yes, sir.
I believe we saw your Zoom meeting at Jacksonville, Beekeepers in Jacksonville. A question was brought up, and I don't know if it ever got to you. Did the beer actually draw more beetles into the hive, or did it actually get the ones that were in the hive already? That was a question that was brought up at the Zoom meeting.
Right, so generally how these attractants work is the odor isn't strong enough to actually reach outside of the colony. Generally, it's an in-hive attractant, so the beetles that are already inside of the hive, it's those that are attracted.
We were worried about it attracting actually beetles to the hive because it's such a good attractant.
Right. So beer was shown to be significantly different from all other compounds. question.
Did you put the beer with like mineral oil, or was it just the beer itself in it?
So in this study, beer was used just by itself. In phase 2, which I'll get to shortly, I hope we're not running over. But in phase 2, I actually created a blend and it had oil base in it. So one of the concerns that I had was beer is very volatile, right? Especially in humid conditions, it can evaporate quickly. And so I was using vegetable oil, which is a fixed oil, and that really increases the treatment duration. And I'll come to that shortly. But beer is extremely inexpensive. Again, I was using Miller High Life. I used it because it was inexpensive and readily available. And beer does not harm the bees in any way, so you won't have any drunk bees using this. It's just inside of a trap, and these slits are small enough so that only the beetles can actually come in contact with this. Now, coming to phase 2, this was actually where I was developing a novel blend based on the volatile or chemical composition of beer, and I had 2 principal goals in mind. The first goal was to create a cheaper treatment than beer itself, and the second goal was to create a more affordable treatment than beer itself. Now, coming to how I actually went about doing this, the first step in this process was the actual extraction of the compounds from the beer. And these compounds that I'm mentioning are called volatiles. So volatiles are just anything that evaporate very readily at room temperature. Now, in this setup, this is a vacuum, and this is connected to a tube, which is connected to this trap here, this white tube that I'm holding. It's called an adsorbent. So whenever this vacuum is turned on, the volatile odors from this beer bottle are pulled and then trapped inside of that adsorbent and stored there. The second step after extracting these samples is actually running them and seeing what the composition is. So this is done through GCMS, or gas chromatography mass spectrum. What the GCMS does is it takes these adsorbents and then separates the compounds based on their molecular weight. So the lighter compounds and the heavier compounds are separated, and these readings are produced. This is called a chromatogram. What's really important to notice about this is this x-axis here that represents time, and then also the y-axis that represents abundance. But the main thing is really that these compounds here towards the left have a lower molecular weight. And these compounds are of interest for a blend because they are more fragrant and carry more easily in the air, so thus they would be more attractive to the beetle compared to those heavier compounds that really sink. Now, after discovering some of those volatile odor compounds, they were evaluated in electroantenographies, or EAGs. And this is basically where you're able to test the neurophysiological sensory response of the beetle's antenna to specific volatile compounds. So that's a mouthful, but basically, you can see how the beetle is responding to specific odors. And the first step in this process is actually excising the antenna of the beetle. This is a very tricky process. They're 4 to 6 millimeters in length, very tiny. So it's like neurosurgery, but on small hive beetles. Very tricky. But once you get the hang of it, in this setup, this is an electrode. The antenna is placed on here. This is the odor compound. There's a foot pedal that's connected to this, and whenever that foot pedal is pressed, air is pushed through. It carries this volatile odor compound onto the antenna, and then you can generate readings and analyze them. So there were 2 blends that were created, an oil-based blend and a water-based blend, and these were both evaluated in field trials along with beer and a control. This is a trap with that blend and a very high beetle capture. So again, like last year, a lot of stats were run to corroborate this finding. This specific study was run for an 8-week period across 28 different honeybee colonies at 3 different sites. The main conclusion from this was that the oil-based blend was by far the most attractive in this study. You can see this oil-based blend compared to beer. It's 5 times more attractive. So again, this blend, the oil base, was shown to be 5 times more attractive than beer and also 2 times cheaper. And that was the ultimate conclusion from these 2 years of research. Unfortunately, this oil blend isn't available anywhere as of yet commercially, but the beer is the best alternative. That's all I have. Thank you so much.
We have time for maybe 1 or 2 questions. Okay.
What's the oil you use for the oil blend?
So this is soybean oil, vegetable.
Can we move ourselves?
Unfortunately, that blend uses specific compounds from the beer. So it wasn't just beer mixed with the oil. That is something that I can experiment with. You could also experiment with that if you like, using either half and half or a quarter of the oil and 3/4 of beer. But the problem is that the more oil you add, obviously it'll dilute the concentration of the beer and the odor won't be as strong.
So you would need to use something like soy lecithin or emulsifier, I'm assuming, because oil and beer are
With
not.
this blend,
Yeah,
Yes, polysorbate, 20 and 80 were both used as the most important
Okay.
agents.
This is American beer, 3.7%, right? This is not the more powerful beer.
yeah.
So this is, yeah, it's
Yellow
4.6 ABV.
Cheap ass beer.
And one more last thing.
Me?
Yes.
Was it, the hops, the malt, what was it specifically that attracted?
Right, so beer, specifically in Miller High Life, for a lot of beers, the concentration of water is like 90 to 95%, right? And so it's very diluted. The goal with the blend was just to identify specific volatile compounds. It wasn't really identified whether they were the malts or the hops.
So in lagers, you're gonna have very low hop. The
Right.
hop you get in your IPAs and your pale ales and stuff, so this is gonna be more malt. With
Okay.
just a little bit of hop, so.
Right. So, had you experimented with making, malt tea or any kind of hot tea or anything like that? Or do you have a outlook on doing something like that?
I've not
Or
looked into that yet.
just the
Might be
beer?
something
You
for
should
the
start,
future,
what
yeah.
a great group project.
Okay.
Well, thank you.
It's easier to drink the malt.
Thank you. We kind of cut into session time a little bit, so you probably got 5 minutes of a break to your next session starts.
Taste the brew.
Oh, yeah?